Okay, so for the final topic of Chapter 6, I'm going to talk about percent yields, theoretical yields, actual yields, etc. So we talked about doing stoichiometry. We talked about how to calculate how much product you're going to get from a given amount of reactant. That calculated value is called the theoretical yield because we haven't actually done an experiment or we haven't really done the reaction. We're just sitting and doing it on paper. So this is the theoretical yield. This is how much we are calculating that we should get. However, in reality, we never actually get that. There's a lot of things that can happen. The reactants may not react completely. You could have some side reactions happening. You could have some material left in the container. Lots of different things. The actual yield is the truly measured amount of product that you get. So theoretical yield is the calculated. Actual is the real life amount. Now, there's no way for you to know how much the actual yield is going to be unless you either do the reaction, or more commonly, I'm going to tell you in a problem what the actual yield is. It's just, you have to figure it out through experiment. Now, we can take these two pieces of information and calculate something called the percent yield. Now, the percent yield is just a ratio of the two. So it tells you how much of your product you really got, what percentage of the expected or the calculated you really got. Now, in our class, it's a little bit of an academic thing, or more to talk about how accurate you were, how good you were with your experimental procedure. However, when you get up to things like organic chemistry, you get limited by like side reactions and how much a reaction will react. And so a lot of times for organic chemistry and some other branches, of course, you'll get a published percent yield, meaning that, even in, ideal lab conditions, we only get 68% of the calculated percent, so you need to, or calculated product, so you just need to take that into account. So you may see this percent yield, and what it's referring to is it is calculated by the actual yield over the theoretical times 100. And that's really all it is. There's not much more to it than that. So I will give you this problem. Go ahead and try this. And you're going to have to do the stoichiometry first and then find the percent yield. So were produced, it should be. Here we go. So fix that typo. And here we go. Now, so I have 100 and, well, actually, so we have to take a look at this. There's two different numbers. We can't just slam every number down on the paper and just start from there. So I have 125.5 grams of calcium nitride were produced from 29 grams of nitrogen gas and an excess of calcium. What do you guys think is probably the actual yield? It's this. This is the product. This is how much product we got. This is how much product we actually measured. Our initial reactant is 29 grams of nitrogen gas. Now, we have an excess of calcium. We don't have to worry about that. So what I'm going to do is I need to figure out what the theoretical yield is first before I can do anything else. So I'm going to take 29 grams of N2, I'm going to convert it to moles of N2. And what I'm going to do is I'm going to have my, should be 28.02, am I doing that right? Yeah, 28.02 grams of N2 per mole. And then I'm going to do my stoichiometry. We have to do the stoichiometry here. So it's going to be 1 mole N2 per 1 mole Ca3N2. So a little bit boring there, but we would use whatever numbers were appropriate there. And then I need to do my last step, moles calcium nitride, 2 grams calcium nitride. And so I'm going to look those up. So I get 148.26 grams per mole. And so now I can calculate everything through 29 divided by 28.02 times 148.26. And I get my theoretical yield of 153.4. We really only have 3 significant figures, but I'll round off at the end. So now I'm going to take my actual 125.5 grams over 153.4 grams times 100. So that gives me 81.8% is my percent yield. So that's all you really need to be able to do with that.